Welcome all once again, and today my topic of the seminar is clutch, and then clutches, basically clutches and friction material for clutches in automotive application. More focus will be for the friction materials for the clutches, and I will also give an overview about the clutch, and then I will go with the friction materials, different type of friction materials that is being used for the clutches in automotive application. Well, I request the participants to also note down my email ID and mobile number. And if in case any clarification or any doubt, if they want to discuss after the seminar, they can also contact me. So these are all the presentation content today that we have for the seminar. So I will be giving overview about the clutches and the friction material used for clutches, as I said. So first I will start with the introduction to clutches and friction material for clutches, and what are the need for friction reduction in clutches, why we need to reduce the friction in clutches, okay? And different manufacturing process and parameters for friction material. In fact, I will also cover the clutch as well, clutch and also for the friction material, and the different friction materials that are available for clutches. And uh, the different manufacturing process used for sir, I request you to admit the participants as well. Okay. Different manufacturing process and parameters of friction materials, different friction materials that have been available for clutches, performance of clutches with the different friction materials, development of the clutch friction materials, and different tests for clutch and also for clutch friction materials. And I will be covering the two case studies with respect to friction materials, how it is influencing the efficiency of the clutches. And finally, I'll be concluding my topic with the topic on to the friction materials for clutches. First, the topic is introduction to clutches and friction materials. So, what is the clutch is all about? Clutch is nothing but a mechanical device that engages and disengages as I said, the clutch is a mechanical device that engages and disengages the power transmission, especially from the driving shaft to the driven shaft. So in these devices, one shaft is typically attached to an engine. So you call as one part to the engine and another part to the driving member or the power unit. So you have one driving member and one driven member. Finally, you get the output power for work. So how the clutches are being performing, or how it has been working. So the clutch connects the two shafts so that they can be either be locked together and spin at the same speed, or it can be decoupled and spin at the different speeds. Clutch allows us to smoothly engage a spinning engine to a non-spinning transition by controlling the slippage between them. And as I said, the friction material, why this friction material is being needed in the clutch? Okay, that is the most important topic of today session as well. So we need to have the friction material because they offer a good combination of smooth engagement, wear resistant, and also the strength. Before going to the friction materials, we will be giving more about. I will be giving an overview about the clutch, different type of clutches that you have, and then what are the clutches that is being used across the automotive application for different vehicle platform like two-wheeler, three-wheeler, or a four-wheeler, or a commercial vehicle, or a trucks, or buses. The clutch has been generally having different parts. So one end of the clutch is connected to the engine, another end to the transmission. As I said, the clutch is having different parts. It is having the clutch disc. It is having it is having the flywheel. The rear end of the crankshaft is connected to the flywheel. You have the clutch disc, which is located between the flywheel and the pressure plate. So this is location where clutch plate is a location where you have the friction material. Okay, and again there are other parts of the overall clutch. You have the clutch housing. So I'll give an overview about the clutch housing as well. How the clutch housing, you need to design the clutch housing, and you also have the clutch fork, and you also have the stud. You have the clutch linkage and the pressure plate as well. Um, and the flywheel is a part that is been permanently fixed to the engine crankshaft. And as far as the friction surface is concerned, I told you you have one surface connected to the clutch disc, and one end of the clutch is friction is connected to the pressure plate, and another end to the flywheel. And you also have the springs, diaphragm spring. You also have the clutch plate spring. I will explain that in this slide. Uh, so these are all the different parts of the clutch. You have the flywheel. I told you this is how the flywheel looks, and they said you also have the transmission unit, which has been one. The other end is been connected uh, to the transmission side. Uh, you have the different components involved in the clutches. So, for example, you have the flywheel, you have the clip, you have the pressure plate, you have the finger release finger, you have the strut, you have the bolt, you have the fulcrum spin, you have the clutch cover housing. It's a housing, and it protects the complete clutch, and you have the coil spring. So this is how the friction disc friction material looks. One end of the clutch disc and another end to the flywheel. And you have the hub, you have the bearing, you also have the fork, which I have explained already. Well, we have different type of clutches. The the one what we are using it for automotive application, you normally have the friction clutch. And in fact, you have different type of friction clutches. So one is single plate clutch, and another one is multi plate clutch or a cone clutch. And there are other type of clutches have been used in automotive application. For example, the centrifugal clutch use semi-centrifugal clutch, diaphragm clutch, and dog and the spine clutch. But for our automotive application, we go with the single plate clutch or a multi-plate clutch mostly. And in fact, even cone clutch also we use it for some application. Say for example, the single plate clutch has been mostly used for the, the light duty application and also for cars. And basically, this multi-plate clutch been used for race cars. Okay, where you need to have that high performance. At the same time, it is also been used for some of the applications of the trucks, commercial vehicles, as well as for off-highway. And even you also have two type of clutches. One is dry clutch and another one is wet clutch. And in the case of wet clutch, you use the lubricants. In the case of dry clutch, you do not have you don't need to have uh, the lubricants basically. So the topic here is the friction material. So this is the raw material that is being used for manufacturing the friction material for the clutches. And the friction clutches, as the name indicates, it involves the friction material. And we use these friction clutches for all our automotive application. So the friction clutch is a clutch in which the drive is transmitted by the friction between surfaces attached to the driving and the driven shaft. These surfaces are aligned with cork, asbestos, or other fibrous materials. Friction clutches are by far the well-known by this type of the clutches. And these are the different type of clutch that normally you have. This and again the clutches are being classified based on the type of actuation that is being normally used. So you have different type of actuation. Basically, you have the mechanical actuation, you have pneumatic, electrical actuation, and magnetic actuation. And here, so the friction is very much important with respect to the category is concerned. You have cone friction clutch, drum friction clutch, and disc friction clutch. And you also have the overrunning clutch and other electromagnetic clutch. Even you are going for this type of electromagnetic application, even for some of the application like the electric wheelchair kind of thing. Okay, even even there it plays a vital role where you use electromagnetic application. Even for a kind of electromagnetic brake application, also you can be used. But here, with respect to the application is concerned, with respect to clutches, as I said, the friction is very much important with respect to the automotive application. And you also have the hydraulic clutches as well. So coming back to the friction clutch, this has been mostly used, and even this friction clutch, even you have the friction in the case of brake as well. But today our topic is with respect to only the clutches. So you have two or more surfaces which have been normally facing towards the friction side. So you have the friction material in which this is basically the clutch plate, and one end of the clutch plate is connected to the flywheel, another end of the clutch plate is connected to the pressure plate basically. And here, what you have is you have the surfaces which is made up of a metal. It can be a steel metal, and there are different type of material, okay, in which you use this friction material as a combination. I will explain those things as well during the session. And the frictional contact can also occur radially. It can occur radially, or it can also occur cylindrically, or it can also occur axially. And this is the clutch plate basically. You have the friction pad. This is how the friction pad looks. So we are going to see what are the different type of friction pad that we have, and at the same time, how the design should be there that will improve the efficiency of the clutches. I will going to give an overview about this friction pad and the design of the friction pad along with the clutches. So what is the function of the clutch? Okay, let us talk about the clutch first, then we will go with uh, the then we will go with the different type of material that is we normally use in the case of a clutch. So you have the clutch in which when you have two type of operations. I mean, application one during the engagement and another during disengagement. When the clutch is engaged, what happens is the power flows from the engine to the wheel to the transmission system, and the vehicle moves. This is a normal phenomenon that the clutch is normally being applied and being used. And what happens when the clutch is disengaged? So when you're disengaging the clutch, the power is not going to get transmitted to the wheels, and the vehicle stops while the engine is still running. This is the basic funda of a clutch. And the clutch is always kept engaged when the vehicle is moving. And the clutch also permits the gradual taking up of the load when properly operated. It also prevents the jerking motion of the vehicle. And during the following 4 conditions, the clutch is disengaged. So when you're starting the engine, when you're shifting the gears, and when you're going to stop the vehicle, and when the engine is kept idle. So under these 4 conditions, the clutch is in disengaged position. So when you're designing any clutches, normally we in a company we do the clutch design. So when you're doing any design, we always look for these applications or these parameters. So we need to understand what is the torque transmitted for the particular vehicle, and accordingly we need to design the clutch, and how much means what is the gradual engagement, how much should be the heat dissipation, and the dynamic balancing. This is very much important requirement of a clutch. We also need to provide the vibration damping, and the size means how much is the inner diameter, outer diameter of the clutch plate, the pressure plate. So all this design is very much important, and it also functions such a way the free pedal plate should be much more smoother, and it is easy for operation, and the weight should be lesser. The overall weight of the clutch should also be lesser. These are all the requirements that normally when you're doing any design in a clutch, we normally look with respect to the company point of view. Okay. This is one of the technique called FAST technique, is called functional analysis systematic technique diagram. So we perform this type of diagram or the thing for any application. Okay, this normally we use it to achieve the value to any product. So this type of thing can be applied to a clutch or a brake or a transmission or a engine or a flywheel or a tire or a frame or a chassis or whatnot. Okay, it can be applied for any application. Okay, and this technique called fast technique is necessary basically to identify the different functions that the particular product is going to exert while you are going to design the particular product. And basically this fast technique is being used as a part of a value methodology or value engineering technique. So here, what is the basic function of your car? If you are going for any design, you need to understand what is the basic function of the particular product. So here, the basic function of a clutch is to transmit torque. What are the other functions that the clutch is going to have? Generate motion, is generate pressure, distribute load, it also transfer force, and it also apply force. And I need to follow the logic called how logic and why logic. So why I need to transmit torque to transmit power. So when I ask the question why to the basic function becomes higher order function, I need to design the clutch basically to transmit torque, which in turn will transmit power. Now I'm going to ask the how question: how I can transmit power by transmitting torque? How I can transmit torque by generating motion? How I can generate motion by generating pressure? How I can generate pressure by distributing load? How I can distribute load by transferring force? How I can transfer force by applying force? So again, going to ask the question why. Why I am going to apply force, right? Transfer force. Why I need to transfer force to distribute load? Why I need to distribute load to generate pressure, to generate motion, to transmit torque, and also transmit power. And what is my design objective? I need to design the clutch such a way that noise should be lesser. It should resist vibration. It's maintain position basically. Integrative called as a position. You also need to design for supporting load. You should make the specification, as I said, the diameter, the material, what material you're going to use, and standard also you need to meet. And again, that it should you need to design the clutch such a way it should withstand the temperature, and also it should also withstand the pressure, and should also minimize the friction. Basically, it should minimize the friction, and should protect the product. Means the manufacturer should protect. They should ensure that the protection is there, and they should also ensure warranty. And apart from that, it should have better reliable. It should be much more durable. and it should resist corrosion. It should have better aesthetic features, and it should also ensure hardness. So when you are designing any clutches, you need to look all these functions, and all these functions are being considered as a part of design and development activity of clutches. And we consider the scope between the left scope line and right scope line as the scope of the project. And this is how we consider every function, and we ensure that all the functions are met for this particular product called clutch. Same, we can also follow it for some other product also. Since we are going to deal with the clutch and clutch friction material, so I have drawn the fast diagram only with respect to the clutch and friction material for the clutches. The clutch housing is one of the part where this covers the complete clutch. Basically, this clutch housing is basically used for protecting the clutch, and it takes load. Basically, the basic function of a clutch housing is to sustain load. How you can sustain load by supporting object, how you can support object by ensuring engagement, how you can ensure engagement by assembling part and by aligning part and transferring force. Why I need to transfer force to a clutch housing to align parts, to assemble parts, ensure engagement, support object, sustain load, and basically this is used for performing the operations. The one what we have seen here is a technical fast diagram, called as functional analysis systematic technique diagram, and this is nothing but a customer fast diagram. So when you're designing any product, here is a clutch. So when you're designing any clutch or a clutch housing, what customer normally looks when they're going to use the product, they look for convenience, they look for dependability, they also look for satisfaction, and it should also attract the user. How the company manufacturer, okay, I am going to give you the list of company who are already manufacturing this clutch friction materials. So as a manufacturer, what they need to assure the customer, they need to assure the convenience, dependability, user, and also user in terms of satisfaction and also aesthetic point of view. So first we'll talk about the convenience. When I talk about the convenience, you're going to provide access to them, easy for them with respect to the approach or with respect to the service. Suppose if in case any issue with respect to the service. So first, what you do is you remove the clutch housing, then you go with the clutch, and you go with the satisfaction with respect to the safety point of view. And see, this is very much important, the noise level. Normally, when you are running the clutches in a vehicle, sometimes you have the clutch noise, right? So when you're designing anything, you need to have some decibel level, for which you need to design the clutch. And we do a lot of testing as well. So we do noise test, vibration test to ensure that the level of noise and level of vibration is well within the limit. And we also need to ensure that with respect to the user point of view, it should have better rigidity, and the quality is very much important. The strength is very much important. It should be free from corrosion. There should not be any leakage, right? Not only with respect to clutch housing, even for a clutch, okay. And it should not block particles. It should not allow any particles basically. And there should not be any gap basically. There should not be any gap in the clutch housing, okay. So when assume that this is the clutch housing, okay, there should not be any gap. So it should be sealed properly. And if there is any gap, what happens? It may lead to leakage, and as a result of that, it may affect the clutches basically a friction plate clutch, you call what you call the pressure plate, okay. And as a result of that, the performance of the clutch also goes to the low level. And it should also do such a way the force transfer, okay. So when you are engaging or disengaging the force, I mean the clutch basically, what happens when you are engaging or disengaging the clutch? The force, or you are going to either apply or supply, or you are going to remove the force. Accordingly, the force either gets transferred or gets transferred, and accordingly the load gets distributed, or the load is being applied or load is being removed, okay. And similarly, the pressure is that you are going to get the pressure or you are going to remove the pressure. Similarly, you are going to the clutch plate or the pressure plate is going to rotate or it is going to be in ideal position. Either you can transmit the torque or retransmit the torque. Okay. So these are the things you are going to do. So as a result of that, what is important is when you're designing the clutches, what is important here is you need to ensure that you are going to satisfy the user or a customer considering um, uh, the utilization with respect to the reliability, durability, strength, with respect to the performance, without affecting the function of the clutch. Okay, that is very much important. And there are some other parts, I mean, other thing with respect to the manufacturing is concerned. So you need to reduce the cost of the product, lead time, the manufacturing time you need to reduce, and also the quality should be free from the quality issues. Basically, you need to reduce the rejection, and these are the other point of view with respect to the customer point of view. Um, so this type of drawing called a technical fast diagram or the customer fast diagram, you can use it for any application, not only to clutches, but since the topic today is clutch and friction material, I'm going to I have given this drawing to you. Why we need to have we'll go with the need for friction reduction in clutches. So why we need to have basically friction reduction in respect to the clutch point of view? What is the necessity? We need to have the friction will be reduced by adding lubricants. So basically, we are going to have the friction material to increase the life of the material. Okay, to life of the clutches basically. So here the material indicates the complete assembly, which is nothing but the clutch assembly. And here the purpose of the lubricant which is being used to reduce the friction between the two surfaces. One surface is attached to the pressure plate, another is attached to the flywheel. And here we provide the lubricant, basically the base oil can be mixed with oil or it can be mixed with grease. And accordingly we create a chemistry to look for the friction reduction between the two surfaces. And here the goal is to reduce the amount of friction, and it will also help for gaining the fuel economy. And again, you're also going to use the friction modifiers that have been used with respect to the clutch point of view, and it will either increase or decrease the friction. But this helps for also reducing the shear force into the clutch plate, into the friction plate, or into the pressure plate, or into the flywheel. And this friction reduction is very much important because it helps for a smooth transition from the dynamic condition to the static condition. Basically, when you are changing the gear, or when you are engaging or disengaging the clutch. So we'll see the manufacturing process and what are the different parameters that we have been using it for the friction material, basically for a clutch friction material. I have shown you the raw material, how it looks. The raw material, how it looks will vary from application to application. This is one of the raw material basically made up of ceramic fiber, and this is the end product basically. This is one of the end product, not the complete end product. So when you're going for the manufacturing process, the first step is to blend the raw material, and here you see the composition. You have different type of composition, and what we are going to have is to have the thermal resistance and the friction characteristics as well for this composition. You need to select the composition such a way it should be free from it should have the thermal resistant property as well as the friction characteristic property. And when you're going for a blending of the raw material, you also need to see the strength and the density of the raw material such a way it is having the peeling resistance. It's not peel off. Okay, so it is basically sticked into the clutch plate. And during the operation, when the clutch is rotating, the peeling of strength or the strength should be much more higher. It should stick itself to the clutch plate. Okay, it should not peel off. And again, you also need to ensure that the friction characteristics is been met for a particular application. And after blending, what you're going to do is you're going to do the impregnation of the resin along with the hardening process.
Wow.
Where it will also increase the peel of strength and also the abrasion resistance strength. Finally, what you're going to do is you're going to bond into the core plates. Then you're going to have the final density of the particle. So these are all the parts, the manufacturing products of the friction plate, friction process basically. And finally, you're going to ensure that you're going to have the bonding of the clutch plate, which will have the strength. At the same time, it will also withstand the vibration. It will not come out as it is, like it is having the peeling of strength, and also it's having the abrasion resistant properties as well. So we have different parameters of the friction material, and this based on the manufacturing process and based on the different parameters. And this is some set of readings taken for 7 trials, 1 to 7 trials, and these are the average values with respect to the specific molding pressure in terms of MPa, molding temperature in terms of degrees Celsius, and molding time in terms of time in minutes, and heat treatment temperature, and also heat treatment time in hours. And these are some of the readings taken only for first three, and still FT4, FT5 is not shown here. And this is the average value. Okay, say for example, the specific molding pressure is between 45 to 70 MPa is the one that is being used for the friction materials, and the molding temperature ranges between 155 to 175 degrees Celsius, and the molding time between 5 to 12 minutes, and with respect to the temperature of 200 to 250 degrees Celsius, and the heat treatment time is 5 to 12 hours. So when you're designing the friction material for the clutches, so you need to consider all these manufacturing parameters, and you need to select according to these parameters, you need to design the friction material for manufacturing that particular friction material into the clutch. So you have different friction materials that are available for clutches. So when I'm explaining the manufacturing process of a friction material, I have told about the bonding strength. Okay, how from the raw material, how you can go for a bonding, and how you can increase the strength without affecting the performance of the clutch through these friction materials. So you have different type of materials with respect to the friction for a clutch. You have organic materials, you have heavy duty organic lining, you have ceramic material, you have Kevlar, you have Ferramic, and you also have the Ferram Alloy Lining. We have different friction materials, and depending, you need to use these different materials for different applications depending upon the load that the particular vehicle is going to have, because the load acting on two-wheeler is different from the passenger car, and the passenger car load is lesser than that of the racing car, and when it goes to the truck or commercial application, the load application is different. So you need to select the friction material considering the clutch application where you're going to use this particular thing, and that's why you need to select the material with respect to the application and also with respect to the cost. Okay, so cost versus the performance is very much important. So as I said, the bonding materials, the bonding of the raw material into the resin is very much important to achieve the friction property with respect to the peeling of strength or abrasion resistant strength or overall hardness, etc. So here, with respect to the bonding material classification, the friction materials are being classified as 4 types. One is its compounds with asphalt base or with respect to the vegetable gums, rubber, and synthetic resins. So I have told already with respect to the location where the friction material is being used in the clutch plate. This is the material. This is the location where the friction material is located, and this is basically located between the flywheel, and also you have one end to the pressure plate, to the top of the clutch plate, and this clutch plate uh, is been splined with a mesh with respect to the input shaft. You have the input shaft, and this friction material is been reverted. You have the reverts here, right? When reverted to the cushion spring, you have the cushion spring. This is the cushion spring, and on either side of the friction ring, this has been reverted. Okay, this is one side, and another side also looks similar to this, and both the sides are been reverted with the help of a reverse. And you have a splined shaft or a splined hub. This is a splined hub. It's been meshed with here. Here we have the input shaft basically. So today the topic is more about the clutch friction material rather than clutches, but I am going to correlate this clutch along with the clutch friction materials. The first important material, friction material, what we are going to use is Ferram Alloy facing material. And this is the new material which have been likely to replace the ceramic facing. And this Ferram Alloy offers a similar level of air and temperature resistance compared to that of the ceramics. So you have ceramic material, right? So this is the one of the alternative to a ceramic material, but with a much better static to dynamic ratio. Here, the static to dynamic ratio is much more better than that of a ceramic thing, and even this helps for the better engagement, smooth engagement of the clutch. When compared to the ceramic material, this Ferramala is much more better. And the other advantage what you have is you also have the noise of chatter noise. Okay, you have the chatter during the engagement and disengagement of the clutch. And when you're going for this Ferramala facing, uh, this type of issue has been avoided, and rather than going with a ceramic facing, if you go with a chatter based, means when you go with the Ferramala alloy facing, you tend to have lesser chatter issue. And there is one company called a Phoenix friction manufacturer. So they are the first clutch manufacturer to begin use this Ferram alloy facing. And this Ferram alloy is basically used for a heavy duty application. And here you have the diesel trucks, commercial trucking, etc. And the next important thing is the organic friction material. This is one of the picture of the material of organic friction. And here this has been almost used in all cases. And here you have two type of organic friction material. One is molded facing, another one is woven facing. And in many cases, woven facing is better than the molded one. And this we are going to use for a better combination of performance, durability, drivability, and cost. Okay. And when you're going with the organic facing, you have material that are made up of resins, phenolic resins. You also have the friction modifiers like metallic powder. So I have some of the powder, and this can be mixed with some metal oxides, or it can be compounded with rubber. And this the friction facing or friction material facing, it comes in two types, as I said. One is the molded one, another one is woven. Woven is somewhat better than the molded one. So for the same comparison between the outer diameter of 11 inch and the inner diameter of 6.5 inch, okay, for the same design of a clutch plate, okay, for the same design of a clutch plate, you see here the woven facing, it can run up to 10,000 rpm, whereas the motor facing can even burst at 5,000 rpm. Okay. So the problem here is with respect to the motor facing is that the strength is the problem. Okay, and it is very cheap. With respect to cost, it's okay, but the strength is very much important. Okay, what happens because it is running at a high rpm, the clutch plate is rotating. when the vehicle is in operation, what happens? Okay, uh, during the when it is lacking strength, okay, when it is lacking strength, it is having the problem with respect to durability, and sometimes it may also lead to drivability issue. Even though the cost is lesser, this too is going to get affected. As a result of that, the performance of your overall clutch gets reduced. Okay, so this is how I'm going to correlate your clutch friction material with the clutch also. Okay, so you need to select the friction material considering the life of the clutch as well. And here, the wound facing is much more better than that of a motor facing. And uh, all the OEMs, okay. So I have been coming from a company of many OEM background like Bharat Movers, BML Limited, Mahindra. BML is a commercial off-highway vehicle, and Mahindra is also into SUV category and passenger cars. And PSA, my previous organization, is also into the SUV and uh, car manufacturing organization. So during my experience, what I come across is so whenever you are designing any clutches, okay, I myself have evaluated many suppliers with respect to the clutch durability and also clutch testing when I'm carrying out the design for the clutches. So during my experience, what I come across is the friction material is one of the very key important thing when selecting the friction material is very much important thing when you're designing the clutch also. Okay. You need to give equal importance for the design of clutches as well as selecting the friction material and evaluating the friction material during the testing. And in fact, I have discussed with many suppliers. I am going to list down some of the suppliers whom I have also contacted, and in fact, how those suppliers help the organization, help the OEM to achieve the smooth engagement of the clutches and the wear resistance and strength. So I'll explain that during the process. You have one more the next application called heavy duty organic. I request the people not to scribble. She is getting disturbed. Okay, you can take away the scribbling. Good. So the, the next application what we are going to use is a heavy duty organic thing. Um, this heavy duty organic clutch facing is similar to the normal organic clutch what I have been shown in the previous slide. And one more advantage is that the temperature resistance is much more higher than what had been seen here. Okay, so the temperature withstanding capacity is much more better uh, with respect to the organic friction clutching. Okay, and say for example here the heavy duty organic clutch facing features it features more metallic content. It will also boost the high temperature resistance and also it reduces the fade. You have the friction material like this. The fading, it means the loss of material is going to be lesser in the case of heavy duty organic rather than going with the previous types of friction material. And this gives the clutches the resistance to temperature and it also withstand the temperature up to 370 degrees Celsius. And this also mean much more better for a short period at the same time. This also increases the burst strength and this type of things are used. And as the name indicates, heavy duty organic it's been used for a heavy duty application, mostly for towing application, hauling, overhauling, and also for street performance application. And they are temperature resistant at the same time. They are very strong and they are very durable and still they are very smooth. And this is the most commonly used material that you have seen. Okay, ceramic friction material. This is quite common. Uh, And this ceramic touch facings are made up of a mixture of different compositions like copper, iron, tin, bronze, silicon dioxide, and also graphite. The material is been done using the process called sintering or bracing onto a baking plate, and this also been reverted into the. I have told you when you have the reverting operation, okay, so you need reverted with the help of a bolt, and this has been reverted to the main clutch plate. This ceramic clutch facing material can withstand high temperature, and it can operate without any issue or without any fading, loss of material up to 538 degrees Celsius. So higher the temperature, so you have also advantage. And this has been mostly used for a racing application where you go for a the multi-plate clutch if required, and this has been required for a racing application because there the performance and the speed and when the speed of the vehicle is more, obviously the clutch is going to get engaged during the operation, or again during the cornering. You need to sometimes you need to also go for some disengagement. So considering that engagement or disengagement, especially in the racing car, the performance is very much important. Okay, in such application, you go with a uh, ceramic application, means ceramic material. Okay. Uh, so here also the ratio between the static to the dynamic friction is also quite high, and which means the clutch engagement can be abrupt. Again, here they are good for racing situation, so because where you get a continuous repeated engagement, disengagement, engagement. Why it is leading to the high temperature? Because you have continuous engagement, okay? Because you need to win the race, and you're going for a winning the race or participating in the race. You are not going to run your vehicle in low speed or a medium speed. There, the maximum speed will be too high, okay? And in such scenario, the temperature obviously goes to the higher level. When the temperature goes to the higher level, what happens is the friction is going to be higher. When the friction is higher, you need to take care of the friction material between the clutch plate, the pressure plate, and to the flywheel. Okay, so when there is a fading of the friction material, there is a fading. What happens is property goes to the uh, lesser side, and again the performance will be an issue. When the performance is less issue, then what happens is uh, the clutch issues can also happen during the game or during the operation of the vehicle. So you need not to avoid all these things. You need to go for a better material which is made up of a ceramic thing where even it can withstand up to 530 degrees Celsius. The last the friction material is nothing but the Kevlar friction material, and this is how it looks. You can see that um, and even the grooves. It is the groove. Okay, it is made up of a square kind of thing. So here, even when you're designing the clutch plate, you're also going to select the best groove for the clutch plate. Okay? I am going to explain that as well with the help of some case studies. And you have the internationally trademark of two material called Kevlar and Toran. They are the worldwide trademark which is being used for Aramid fibers that are been often used to make the clutch disc. And here, this clutch is made up of the Kevlar is better for longevity and also for smooth engagement. And the clutch plate having the Kevlar is having 2 to 3 times longevity in the sense it respect to durability point of view. The vehicle, the average life of the or warranty is 2 lakh kilometer. Okay, when you're using the 2 lakh kilometer or something like you call as 3 years warranty. What happens is when you're going with a Kevlar, you, you are your longevity goes to a higher level. Instead of 2 lakh kilometer, you can also give a warranty in a better manner, stating that my clutch plate or my clutch will withstand up to 3 lakh kilometer. Okay, and that type of confidence you can give it to the customer. And again, this Kevlar material is having low static to dynamic coefficient, and it is also since it is having a low coefficient of static to dynamic friction ratio, and this is made as a ideal choice for application where you have the smooth engagement is required. And this has been mostly used for a off-road driving, okay, and it's also used for crawling operations. And here this Kevlar facing, it can perform, which needs to have higher clamping pressure than most material what had been discussed previously, which includes organic or a ceramic or a Ferram Alloy material. And it can, as I said, you have a higher longevity. And you can continuously run and in a period of without any break. Continuously can run it for 1,000 miles also. 1,000 miles, in terms of kilometers when you convert, even you can run continuously. Say for example, even up to 1,500 kilometers you can run it continuously. That type of test has been carried out using the Kevlar material for this off-highway roads basically. And this Kevlar is the world-renowned internationally trademark material for this friction. And as I said, this is better for smooth engagement and better for longevity. This in terms of torque rating, it is also better to the torque rating, uh, but on the other hand, you also have the heavy duty, okay, heavy duty organic facing. Um, uh, we have seen also the heavy duty organic facing, but with respect to the strength point of view, it plays a vital role when compared to the Kevlar material. But on the other hand, with respect to the longevity, this is better than that of organic material. Now we'll see the performance of the clutches with different materials. So how the, the clutch is going to perform without friction. So why you need to have the material in any clutches? What is the need of having the friction material in clutch, and how the clutch will perform with and without friction material? I'm going to highlight only the very important points because we have a lot of points to discuss, but I will just highlight only the important thing. Clutch performance could have been improved by grooving the friction material to allow the wear debris to escape from the permanently contacting surfaces. So I'm going to give you one case study where the grooving of the pattern, which will play a vital role in increasing the resistance at the same time. It will also help for reducing the friction of the clutch. And the performance of the organic material with respect to the sinter friction material with and without the friction material. What is advantage is that you have the better thing with this, which will also take for help for reducing the load to the clutch. When you're reducing the load to the clutch with the help of this friction material, friction facing material, you are going to reduce the temperature. You're also going to reduce the force during the clamp up or clamp down, and you're also going to operate the clutch with the maximum work output or input at the same time. You're going to get the better output as well. And see here, the important thing is when you're designing the clutch plate in the clutch, you need to have the friction material having the grooves. And if you're going for ungrooved material, the performance is not that much higher with respect to the grooves what you have. And again, these grooves will tend to have the cooling effect as well. So when you have the cooling effect because of the high friction that you have, when you have the cooling effect, what happens is the dynamic coefficient of friction did not change, and when the dynamic coefficient of friction is not going to change, basically the static friction should be higher and dynamic coefficient of friction should be lower. So when you have lower dynamic coefficient of friction, basically your high temperature, it will not go to the high temperature basically. So that is one advantage that you have when you're going with the friction material when you're designing the clutch. So we'll see some of the development of a clutch friction material that have happened recently. We have different type of friction materials that is been used for brakes as well as for clutches as well. I'm just going to touch upon the brakes as well because the friction is quite common even for the brakes as well as for the clutches. But uh, clutch is quite sensitive when you are going for a design, because brake is also very much sensitive. But here, the topic today is clutch. We will see it more into the clutch application of the friction material. So we have seen many types which involves ceramic, Kevlar, Ferram Alloy, organic for a heavy duty and for a woven application. And here, friction material types are being categorized into for clutch is been classified as clutch facing and clutch disc, even for clutch material and clutch sets, and friction disc as well. So in the case of friction clutch, what you have is a friction disc. Basically, we have multi-plate clutch where we have many friction disc as well. And with respect to the brake, you are going to use this friction material in the case of brake pad. And again, it can be with respect to the disc application, or it can be a ceramic application for the brake pad, and brake lining, and also for a brake band, and also brake locks. Also, this friction material playing a vital role. There are many leading manufacturers of the friction material across the globe. These are some of the companies. In fact, when I'm working in an organization like the clutches, means respect to the PSAR in Mahindra, um, what I do, I don't interact with the clutch friction material manufacturer. I normally deal with the clutch manufacturer, and in fact, these clutch manufacturers will interact with these manufacturers with respect to the application, how to reduce uh, the fading property, how to increase the filling of strength, abrasion strength, the bonding strength. So in fact, they communicate between them. And these are some of the leading manufacturers across globe who are into the friction materials, supplying to the clutch manufacturing company. Uh, and the company name is Cook Bonding and Manufacturing. It's again international based company, and they also apply it to some other industrial heavy duty application. Even also, they also use it for some of the application with respect to the gear tooth also. Okay, and for some of the press application, even for the customized special products, apart from which also they supply the these friction materials to them. And the other company is Protec, also world renowned company, respect to the supply of the friction material, Seco and Rowland. So this is a very good company, Rowland, and they supply to clutches as well as to the brakes, and even to the gear units. So these are some of the clutch plate suppliers in India that you have. And these clutch plate suppliers, they supply these clutch plates to the clutch manufacturing company, and then that clutch manufacturing company will supply to the OEMs like Mahindra, Tata, or Honda, Hyundai, Maruti. Or if you're taking for a tractor application, Tafe, Mahindra, or if you're going for a um, heavy means truck application, you have Ashok Leyland. The tractor means when you're going for a uh, uh, off highway, you have John Deere, JCB, PML. So here, all those company, all this OEM are going to get the clutch plate is made up of the friction material. So this friction material is being supplied to the clutch plate suppliers, and this clutch plate supplier supply it to the clutch, and that clutch company will supply to the OEMs. So this is how the flow of communication, or the flow of the process will happen. So these are some of the clutch plate suppliers that are available in India. So you have the MK Auto Clutch, which is located in Delhi. You have Amar Clutch Movers Private Limited. You have uh, Descartes, which is located in Jalandhar. You have Jaindai Caster Private Limited. You have in Mumbai, Thane, you have the New Earth Moving Parts Company. You have Balivias Engineering Company. You have MSL Driveline Systems Limited and Ask Automotive Private Limited. So all these companies, they manufacture the clutch plate to the clutch manufacturing company. And with respect to the tier one company, what we call. So these four companies are very important players with respect to the manufacturing of clutches in India. The first is Look India Private Limited, which is clutch case group. So I was dealing with I used to deal with this company more of almost 100% I used to deal with book, and 80% I used to deal with the value. And I started working. I worked for some I during my clutch development in the organization. I was discussing with these two companies, but unfortunately, this XID is a Japanese-based company, and FCC is also is located in India, and but we have not given the order to these two companies. But most of my work belongs to these two companies. I developed the clutch. I have done a design. I have done development. I have done the testing, and the clearance has been given. And both these two companies are good actually, with respect to the performance. But having said that, these two companies are good. It doesn't mean that the other two companies are not good. They are also having the capability, but with respect to the application, what is been required for Mahindra or a PSA, not able to uh, um, meet in the sense the confidence level is not been obtained between these two companies rather than these two companies. Okay, so these are some of the friction material that is already developed in the market. You can see the clutch plate facing made up of clutch friction material. You can see the shape how it looks. It's something like straight, but you see there are a lot of process. Okay, you, you have different the shape itself. Okay, and even this shape is much more better in terms of uh, the heat withstanding capacity, but at the same time, when you go with this one, what happens that the design is slightly complicated rather than this. Okay, and you can also make the friction material made up of Kevlar along with the carbon composites as well. So Kevlar, as I said, uh, Kevlar has been mostly used for longevity application. And when you're going for long durability things, and when you're using the Kevlar along with the carbon composite, then still the performance can be much more higher. You see some of the material combinations. So you have different material combination, and again you have different coefficient of friction and different temperature and pressure for which you need to select the clutch plate, and accordingly that will also influence the friction of the overall friction, and that will also increase the performance of the clutch as well. We have different combination. This can be the clutch plate can be made of cast iron, having it can be suited for wet application or dry application, having different temperature range between 300 degrees Celsius up to 500 degrees Celsius, and even the pressure can also vary up to maximum of 3 MPa, or which is called 3 into 10 to the power 5 Pascal. Okay, and you see you can also have a combination between cast iron and steel, and you also have the combination of I told you you have different asbestos material, you have the cork material, you have the woven material, woven asbestos, molded asbestos, but this woven is much more better than the molded one. And you also have the Kevlar. So for a different application of the friction material along with the material combination, Kevlar can be applied with the cast iron, and even the asbestos can also be used with the cast iron. And depending upon the application, you can also look. You need to look for the design of the clutch plate, and you have the material combination with respect to the different coefficient of the friction and the temperature and as well as pressure. So you have different friction materials here. So I told you molded one, woven, sintered metal, cork, wood, cast iron, hard steel. Okay. Uh, okay. Uh, Hard steel, and at the same time you have the the wood as well. Okay, all these friction materials having different dynamic coefficient of friction. And I told you the dynamic coefficient of friction should be lesser than the static coefficient of friction. So static friction can be higher. Okay. What is the meaning of static friction? So when the clutch plate is not rotating, and even though if I have friction, it doesn't matter. But when the clutch plate is rotating, when it is dynamic position, okay, when the friction is going to be higher, then it is always a problem. So this is where the challenges lies. Okay, even in fact, I have not worked too much about the friction coefficient in depth again, but 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 all this information I got when I'm developing the clutch along with the suppliers. Okay, so this is always a learning process, but the source starts from the friction material and to the clutch plate supplier, and from clutch plate to the clutch company, and from the clutch company to the OEM. Okay, this is a very long process. Even though you might be or you might be wondering why I have taken the topic friction material for the clutches rather than explaining too much only about the clutches alone. So this is how I have started preparing the topic itself. Because you might be knowing about the clutches. Okay, in fact, the different type of clutches, and a lot of research is also going on the clutches. Okay, uh, but my topic of interest, even though I worked in depth about the clutch, I want to give you an overview how this function is playing a vital role with respect to the performance of the clutch itself. Okay, um, because even the clutch design itself is a biggest topic. Okay, you need to design the clutch considering the uniform gear, and you need to design the clutch considering the uniform pressure, or even that itself is the biggest one. Okay, you need to see how much is the torque applied, what should be the inner radius, what should be the outer radius, how you can design the clutch, what should be your the radius, what should be your inner radius, what should be the outer radius, and what should be the material that you need to use, how much should be the number of threads. So all these are very much important when you're designing the clutch point of view. But looking at the performance, you can also correlate the friction importance, friction materials that you can use along with the clutches. So now I'm going to explain you the different type of test that normally you will have for clutches. Basically, it's not only for clutch friction material, but this is applicable for clutch as well. Okay, because we don't have specific test for friction material alone, but we are going to test the clutch friction material along with the clutches, which means you are going to select the test. These are the tests basically that normally you do it for a clutch in any company. When I'm developing the clutch for a look or a value, so we have done all these tests as a OEM. We have done so we have done a gear shifting test for 500 hours, where you shift the gear, right? First gear, second gear, third gear, reverse gear, and the fourth gear, I mean sixth gear. Okay, so different gear you select, and we do it for 500 hours, and we also do the test for 1,000 hours as well. We also do the start-stop test. Okay, continuous engagement, disengagement, engaging the clutch and disengaging the clutch for 1,000 hours continuously. And we also done some tests for 1 lakh kilometer, covering the city durability test to ensure that the clutch and also the clutch friction material is not going to fail. Okay, here the validation for clutch and also for clutch friction material. So basically, this is for clutch, not for clutch friction alone. Basically, it's I'm going to test complete clutch basically, and we are also going to test some of the friction and wear in static condition and also dynamic condition. Why the static condition is required here is because mostly we are going to test the dynamic, but here even some of the static friction is also we are going to test it, so that uh, what we are going to experience is we are going to experience the confidence that the limit is going to be within the specification. And this is the speed, different velocity, means speed in respect to the velocity meter per second you got, and along with that you have the friction coefficient. Um, you see, you have three type of friction coefficient. One is bad friction coefficient, good friction coefficient, too low friction coefficient. You see, the friction coefficient should be higher when the speed is going to be higher. Okay. See, friction is very important. Okay, for some cases, friction is important. Okay, If you have friction, it's good, but at the same time, when you see the graph, it is declining, which means um, higher. I mean, at the start of the test or start of the operation, you see the friction is higher, and friction is going to reduce when it is running. This is not a good sign, but this is a good sign. Initially, the friction is lesser, and when it is starting, it should gradually increase with respect to the speed of the clutch. Okay, and you also have the friction coefficient, which is too low. Okay, but normally, considering these three graph, we always go with a good friction coefficient with respect to the sliding speed. So here the sliding speed is nothing but how it is going to get slided over to the pressure plate or to the flywheel. Here the pressure plate it is also applied continuously with some pressure holding the spring. And that you are going to do this as a part of simulation. You have the computer simulation. What we do is we give all the inputs. What should be the speed of the clutch plate? What should be the friction? What should be the force at which the pressure plate or the flywheel comes into contact with the clutch plate? According to that, how it is we converted that into in terms of velocity, which is nothing but in terms of a sliding speed meter per second. And with respect to that particular speed, what should be the how much is the friction coefficient is happening, and we need to ensure that we are not going to have the very good slipping coefficient. At the same time, we also need to compare that the required friction with the high value and low value. Okay, we need to ensure that the friction coefficient is well within the specification. So now I'm going to close the topic with respect to two case study. The first case study is with respect to the, and again we are going to see some of the failure also, how the failure can happen because of the friction material in the clutch. Okay, the first case study is the dynamic analysis of a single plate clutch using different friction materials. So we are going to use different friction material and we are going to analyze the single plate clutch using the dynamic performance. So the objective here is to carry out the dynamic analysis of a friction plate using different friction materials. So we're going to use the sintered metal where we can reduce the wear of the friction plate. Yes, and then the deformation. These are the values that we are going to get for the friction material. It is being used against a steel or a cast iron. And here the coefficient of friction is between 0.75 to 0.45, and the maximum pressure is 1030 to 2070, and the maximum temperature can go up to 77 degrees Celsius. And there are some of the problems, and you see here, as I said, the dynamic analysis. Okay, when you're going for a dynamic analysis, you may also have some of the problems with respect to the clutch deformation, distortion, basically. Clutch gets reduced, okay, and even clutch gets burst also, even clutch gets crushed, okay, and you would have seen all this problem because of the friction material. All this the clutch can get started or the performance can go lower. The clutch can burst, the clutch can even crash because of the friction material. Say for example, if you're going for unsuitable friction material, if you're not selecting the proper friction material, the clutch can get distorted. And when you're not going for proper lubrication, okay, friction lubrication, and maybe say for example, if you're going for excess oil or grease onto the friction material or onto the opposing phase, what happens is your performance of the clutch gets reduced. So the clutch friction and the friction material and the clutch are directly correlated. Okay, and what is the characteristics? You see the characteristics with respect to the clutch distortion is because of the phasing out of flatness running at a higher operating temperature. When the clutch is underperforming, the performance of the clutch is going to be lower, then it is because of decrease in the coefficient of friction, giving a permanent loss with respect to the performance point of view. And the clutch burst can also happen because of high stress acting onto the facing. That's why the friction materials would also withstand more load, okay, especially when it is running at high speed. And this is because of the material splitting, and then it is getting removed from the plate, basically, the clutch plate. The spinner plate, why it is called spinner plate? It is spinning. Okay, it is spinning around its axis, or it is spinning or rotating about its action when it is in contact with the pressure plate and also in flywheel. And the clutch can also get crushed because of the loss of friction material at the end of the band. And this is because of the crushing and excessive wear of the friction material. This is how the clutch gets the problem of either distortion or crust kind of thing. You see, the complete failure happen because of friction material, and the problem. This is because of the slipping of the clutch, and this is because the friction material coefficient is affected by heat. So that's why you need to select the friction material in a very proper manner. Otherwise, you see, this is the end result. As the temperature goes up, the coefficient of friction also goes down, and the total clutch capacity decreases. And what happens is the heat reduces the friction, which increases the slippage, and finally the heat gets playing a vital role, and finally the clutch drops to zero, and finally it gets slipped away. And these are some of the failure of the clutch, and how it is been related or correlated to the uh, friction material. You see, the clutch slip is going to happen because of excessive grease being applied to the input shaft spline, or the friction material going to get contaminated with the grease or oil to the fitment. Even the clutch failure can also happen because of the oil leak from the engine or gearbox. But the topic here, our interest is with respect to friction material. See, when the friction material is getting contaminated with the grease or oil, even this can lead to the clutch slip. And again, so what is the action for this, or what is the solution? The solution here is to use only grease supplied by the required quantity, and also you need to ensure that the friction is very clean before you fit that to the clutch plate and that into the clutch again. And again, you see, this clutch slip can also be a problem with respect to the facing material being broken away, and this friction material also gets damaged before you fit it to the clutch from the clutch plate. And even you can also get overheating because of due to the slip. And if you are going for incorrect clutch fitted for application, say for example, if you're selecting the wrong clutch plate for your clutch, even that will also lead to the clutch slippage. You need to, the action here is to, you need to handle it with care, and you need to ensure that you're going for a correct clutch with respect to the proper application, and you need to rectify the slipping, and at the same time you're ensuring that you're not going to abuse the clutch during the operation. And even though if you're going for any abusement, you need to ensure that the material is going to withstand properly. And you see here, you have the problem again with respect to the clutch slip. It is also because of the overheated friction material, and the cause here is incorrect clamp load onto the clutch cover assembly. And here the possible driver misuse can also happen by leaving the foot onto the clutch pedal while driving, and the sticking release bearing mechanism, including cable. All this can be the cause. And what can be the action? Here you can go with the correct assembly to suit the application. At the same time, you can go for releasing the bearing mechanism, and without replacing any one or two parts. Okay, this is the methodology that normally you use it for the clutch plate and to a clutch. So you need to select the friction material, then you need to go for a modeling of the friction plate. Then you need to go for a dynamic analysis of the friction plate using different materials to determine the stress. At the same time, the deformation, how much is going to come. And finally, you need to calculate and you need to compare the results uh, with respect to the different friction materials. When you're going for a selection of a friction material, you have different type of grade. Say, for example, you have distal alloy SCA, distal alloy AB, you have distal alloy SC, and distal alloy AE. And this four is been used for different applications. Say, for example, distal alloy SCA is basically having 1.75 percentage of nickel, 1.5 percentage of copper, 0.5 of molybdenum, and the grade which has been used for this distal SA is nothing but SC 100.26. And what this distal SA is meant for is, it is meant for the high green strength, and this can also be uh, invest along with the spongy iron powder, and this material having a high strength. It also yields for better after sintering, and it also responds to a better heat treatment process as well. And what is this distal AB stands for? It stands for a chemical composition, and it is similar to that of SA, but is based on the atomic property. Here, this property, the material properties, comes in the form of very fine powder. Okay, whereas this also a powder, but it's in the form of spongy. But here you can see it's not a spongy, but it's in the form of the powder. Okay, and it is having high compressibility strength, and this also responds well to the subsequent heat treatment similar to that of distal ISA. And the next important thing is distal ISC. It is again a spongy iron grade, and it is also having different composition of nickel, copper, and molybdenum, and it also responds better to the heat treatment. And the last one is distal IAE. It is comes in the form of the fine powder having the grade of ASC 100.29, and here this also having the high strength, better for compression, compressibility strength, and it also responds to the high better heat treatment process. And this is the different grade, SA, SE, having different composition, and you need to select the thing considering your compressibility strength, density, yield strength, elongation, the impact strength, hardness. Okay. So I will not say this is better or this is better. Okay. So you need to select the thing is having the, basically we normally go with high strength, high hardness. So here the high hardness goes for the heat treated AE, which is nothing but distal IAE. Okay, we normally go with this distal IAE, which is having a high hardness. Okay, and if what about the impact strength is also much more better here. But you need to see whether this much hardness is required or not. Okay, but at the same time, the yield strength is also higher here, and the transition is also higher, the density is also higher. But this is not good for a compressible strength. Okay, if you want to have a compressible strength, you need to go with uh, the, the grade of E. At the uh, same time, even you can go with the with and without heat treatment. When you're going for heat treatment, then you don't have the heat treatment. I mean, it's compressibility strength, but before heat treatment, you can also have the better compressibility. So you need to see which application you need to have. But when you're increasing when you're going for heat treatment, your strength, your hardness gets increased. Okay, that's why you can see the difference between almost 200 HV gets increased. Okay, when you're going after treatment. And this is a last case study where we are going to analyze the wear factor of a wet clutch friction material with different groove pattern. This is the groove of a clutch plate. Okay, you have different type of groove. It can be either a square type, or it can be you call it square type as a baffle groove, or it can be even a radial groove, or it can be a spiral groove. Different tests has been carried out with respect to the temperature, with respect to the wear. So the wear and the temperature is much more better for a waffle groove having the square shape. And you will have seen most of the clutch plate are having this shape rather than having this shape. The reason behind that is based on the temperature and the wear of this groove pattern friction lining material into the clutch plate along with the clutch, the performance is much more better for the baffle groove rather than for a radial groove and for a spiral groove. Okay, let us conclude the topic with respect to the what we have seen about the friction material and how it is playing a vital role to increase the performance of the clutches. As I said, the clutch friction material are being used in the automotive. It can also be used for the motorcycle application, even for construction machinery, agriculture industries also. This helps for controlling the speed and also for gear shifting in vehicles ranging from tractors to a race car. Okay, it is applicable for all applications. Okay, and this friction material is also having different compositions made up of ceramic or different composite materials being used this way to the clutch point of view. And these friction materials are useful in terms of quality, friction resistance, strength, and these come up with either in the form of a fiber or in the form of a powder. And this is better for the adhesive properties, and this has been reverted as I said you're going to use this in the clutch plate where it is going to get reverted with the help of the bolt into the spring. And this friction materials are often they are very rough at the same time, and they are also textured to provide additional friction, and also it is works for increasing the efficiency of the clutch. And here this also helps for increasing the thermal properties and conductivity and thermal expansion, and ranging for high temperature application as well. And the last one important thing is this friction material will also help for withstanding a high contact pressure. That is the very important thing. And when you have high pressure, you also have a lot of issues with respect to the peel off strength, or the load is too high or stress is too high. And again, during continuous engagement, you also have some fairing issues or high temperature application, and basically this will also lead to the loss of function of the clutch. So in order to save the clutch, the very important thing is the clutch friction material is also very much important. The clutch and clutch friction material always go hand in hand. Um, Thank you for an opportunity. So as I said, you can also email me or you can call me, and my mobile number is 8778 and my email ID is p.arjunraj@gmail.com. Now I look forward for any of the questions if you have uh, over to the organizers. Thank you. Thanks a lot for an opportunity. So I can able to see some of the questions. I will try to answer it from the chat box. So I can able to see somebody from Myanmar also. It's good. Must be match grinder for better engagement. Yes. See, for the better engagement of clutches, you uh, need to have a better grinding also. Yes, you're right. But I can't able to find properly the or friction material used in heat treatment. Yes, you can also use this even for a heat treatment application as well. Generally, friction material are these etc. You're right. Yeah, friction material are the materials used to reduce friction. Yes, you're right. So you're asking the static to dynamic ratio, right? See, the static should be higher and dynamic should be lesser, which means the overall ratio should be higher, right? And if the static to dynamic ratio is higher, okay, it will vary from application to application. Okay, I have shown some of the ratio, but normally if you have a higher ratio, it is better because static should be higher, but dynamic value should be lesser. But on the other hand, if dynamic is higher, then the overall ratio goes to be uh, lower basically. So it should be higher basically. That is what very much important. But at the same time, um, you always need to look for the dynamic ratio, not onto the static ratio. or heavy duty organic friction material used in cranes. Yes, you can also use this organic friction material even for cranes application as well. Fading. Why fading is nothing but what we call is nothing but the loss of the proper material basically. So because you have the continuous friction, you have the continuous temperature application. They basically what happens? It fades. Okay, the material itself gets faded. So the friction material or the property of the material should be free from fading. And for that only you are going with the selection of different material ranging from Ferram Alloy or a Kevlar or a ceramic or organic. And even in organic there is two type. One is the molded one and the one is woven. I told you the woven is better because for the same application I given of the 6-inch and 11-inch OD and ID, sorry, ID and OD. So the one which is used for woven is having 10,000 up 10,000 RPM. Okay, which is the best material to have a longer life of a clutch. Okay. The material combination, as I said, you need to select that particular combination. The, and again, the friction material, as far as the longevity is concerned, you can go for either Kevlar or you can also go for ceramic. Even ceramic is also good, and Ferram Alloy is also good for a truck application. And woven is good. Woven organic material is also good. What are the number of engagement semi directly proportional to the wear of a clutch plate? Yes. See, that's why we do a lot of tests. I have shown you number of tests. Okay. So there we continuously engage and disengage the clutch continuously, and we are going to see after that particular 1,000 hours or the durability test. We are also going to see how much is the wear that the clutch plate is going to experience because of this continuous engagement and disengagement.